So today we are moving to the last portion of our sixth module, that is geometric transformation and RMS error. Okay. So geometric transformation means it is the conversion of existing digital map or image into a GIS projected coordinate system. Okay. So in the first lecture we have studied about different types of projected coordinate system. Okay, and here we are going to discuss about geometry transformation. So it is a conversion of existing map or image, existing digital map or satellite image into a GIS projected coordinate system. So there is mainly two types of geometry transformation, that is map to map transformation and image to map transformation. In the case of map to map transformation, here we are transforming a digital map into a GIS projected coordinate system. That is, if you are transforming a digital map to a GIS projected coordinate system, it is known as map to map transformation. And if you are transforming a satellite image into a GIS projected coordinate system, it is known as image to map transformation. Okay, so based on the data that we are using for transforming into a projected coordinate system, it is divided into map to map and image to map. If we are using digital map as the input, it is known as map to map transformation, and if we are using satellite image as the input, it is known as image to map transformation. Okay, so during this transformation methods, we have to conserve so many parameters, and some parameters may vary. So based on the parameter that we can preserve and the parameters that we cannot preserve, the transformation methods are classified into different types. First one, equiarea transformation, then similarity transformation, then affine transformation, and projective transformation. And in equiarea transformation, it allows rotation but preserves shape and size of the existing map. Okay, here it can preserve the shape and size of the existing map, so it is known as equiarea transformation. And in second type, that is similarity transformation, here also rotation allows, but it preserves shape of the map, but it cannot preserve the size. In equiarea transformation, it preserves both shape and size, and in similarity transformation, shape is preserved, so it is known as similarity. Shape is same, so it is known as similarity transformation. That is, it preserves shape but size cannot be preserved, so it is known as similarity transformation. And third one is affine transformation. It is the most commonly used transformation method. Here it allows angular distortion. There will be angular distortion during transformation, but it preserves parallelism of map. That is, parallel sides remains parallel even after transformation. Okay, that is, it can preserve the parallel sides. It allows angular distortion but preserves parallelism. So that is known as affine transformation, and it is most commonly used method of transformation. The last one is projective transformation. It allows angular distortion and length distortion. That is, here angle is distorted and also length is distorted. That is known as projective transformation. So these are the different methods to preserve different geometric properties. Equiarea, then similarity, that its shape is same but not preserve the size, and here both shape and size is preserved. And in affine, only parallel sides are preserved, and in projective, both length and angle is distorted. Okay, so in these methods, affine is most commonly used one. So it is known as geometric transformation, and affine transformation is most commonly used. So this is one equation based on the coordinate system, but this much is not needed for you. Okay. The next topic is RMS error. Okay. So RMS error is a quantitative measure which can determine the quality of geometric transformation. So in order to measure the quality of the geometric transformation, we use RMS error. So it is a quantitative measure in order to determine the quality of geometric transformation. Okay, so that parameter is known as RMS error, and it measures the displacement between the actual and estimated location of the control points. it measures the displacement between actual location and estimated location of the control points. And here you should by heart this equation, that is RMS error is an indication of accuracy of spatial data and its analysis. So in order to indicate the accuracy of spatial analysis, we are using this RMS error, and it is the square of root of average squares of residual error. That is, here E1, E2, E3 are the residual errors. So it's sum of its squares divided by n, that is the average squares of residual error. Okay, and square root of that one is equal to RMS error. So RMS error is the square root of average of squares of residual error. Okay, so you just by heart this thing only, because too much of this principle is not needed for you. Okay, in 6th module only introduction of GIS is needed. Okay, so you just study what is RMS error. It is a qualitative measure. It is a quantitative measure in order to determine the accuracy of spatial data and its analysis. Okay, and it is the square root of average of squares of residual errors. That's only needed. Problem will not be asked. So this is about RMS error and geographic transformation. So in order to measure the quality of geographic transformation, we are using RMS error. Okay. So by this our 6th module is over. I will share the notes. Okay, if you have any doubt you can ask. Thank you.